So to define a note, we need not only the pitch, but we also need the duration. And Music21 also has this object. It's called duration. So in most of the cases, the duration is given in relation to quarter notes. So for example, if we want to define an eighth note, it means it's a half quarter note. So this is what we're doing here. We can also change the type to, for example, whole. And when we ask for the full name of this duration, it's a whole, and the whole note has a duration of 4 quarter notes. So putting together the pitch and the duration, we can have a note object. So in this case, we're building a note. It's an A4, and we're giving it the duration of an eighth note. So we're setting the quarter length of 0.5. So when we print this note full name and this note pitch, we can see that's A in octave 4, and it's an eighth note, and its pitch it's an A4. So as pitches, note also has this transpose function, and we can transpose, and we're creating a second note, which is the minor third of the first note. So the minor third of an A would be a C. So we're transposing using this function and then printing its full name. And we also need the rests, which are pauses. So we can define using this note rest, and we set whole or half or quarter. We can also define as in relations to the quarter length. So now we have notes. We can also have intervals, which are distance in between two pitches, and we already seen before. And here, for example, I'm constructing an interval which is a -7, and we can print this nice name, which is -7, and it's like relative to 10 semitones. We can also transpose using an interval. So if we create a -7 interval and we define a new note transposing first note using this interval, so we're using the A4, which is defined here, which is note number 1, and note number 3 now is transposing note number 1 using the -7 interval defined here. So the original note was an A in octave 4, 8th note. The transposed note, which is the -7, is the G in octave 5th. And you see that the duration doesn't change, we're only transposing speech. And we can also transpose reversed, so not an interval forward but backwards. So for this we can use this, we reverse the interval and then we transpose, and this is what I'm doing right here. So yeah, we've seen different ways to use intervals and how we can also build scales, and if we get intervals, and we can choose, for example, whole step, whole step, whole step, half step, whole step, whole step, half step, and we can construct where we can give the unison, the second, minor third, perfect fourth, perfect fifth. We can also give intervals like this, as we've seen before. And we also have scales. So Music21 has already some inbuilt scales, for example, like the harmonic minor scale. So we're constructing a harmonic minor scale using this formula, and now we're printing all the pitches that are inside the scale. And we can also use these small functions here, like notes to interval, and we see. So is the harmonic minor is the third, the tonic, major second, minor third, perfect fourth, perfect fifth, minor sixth, major 7. So these are the notes, the intervals that make the harmonic minor scale. Another interesting thing that scales have is called the derived rank. So if we give, for example, 3 notes, which I'm giving here is the is a C minor, is the C, the tonic, minor third, and the fifth. So is the C, the E flat, and the G. And it will derive all the harmonic minor scales that contains these 3 notes. So it's telling me that these 3 notes are in the G harmonic minor, in the E harmonic minor, and in the C harmonic minor. And we find 2 of them on the B flat harmonic minor. So if we construct here the B flat harmonic minor, and then we see that indeed we have the C, we have the E flat, but we don't have the G, we have a G flat. So this is why it's saying that there are only 2 instances of those notes in this this harmonic B flat harmonic minor. So another interesting thing we can also do is to find, for example, a harmonic minor scale that has the note C as the 7th degree, and it tells us that the D flat harmonic minor scale has a C as in its 7th degree. And if we construct here the D flat harmonic minor scale, and we see there's a tonic, 2nd, 3rd, 4th, 5th, 6th, 7th, so it has a C and as a 7th degree. Another interesting thing we can do, and we've seen before, this is what I have a list of intervals here, and I'm constructing minor pentatonic using these intervals. So this function will return me a list of pitches. So when I construct, for example, A minor pentatonic, so we have these 5 notes here, and if we want to see which these 5 notes are inside which major scales, so we can construct a major scale and we can derive the minor pentatonic pitches, and it tells us the A minor pentatonic is inside the G major scale, the F major scale, and the C major scale. So this can be also useful in analyzing sequences of notes and trying to find out what scale it belongs. Yeah. So those are the building blocks. Mostly is in pitch and duration. They are objects that are inside a note. So the note, we can use intervals and scales, and we can also generate a stream. So a stream is a musical score by itself. So in this case, we're just creating a stream, and I'm appending first a rest, it's a whole bar of rests, and then I'm appending the A minor pentatonic notes. So the A minor pentatonic in this function is returning me a list of pitches, but to make a string we need notes. By definition, if we don't specify the duration, it's going to be quarter notes. So I'm converting each pitch from this list to a note. So I'm creating notes, and then here's a list of notes that I'm appending, and we can change how it's displayed. We can go to different clefs. We can put here as a different so 2x3 or 5x4. Yeah, we can include many different things in the string. So yeah, this was a short revision of some objects we've seen so far, and yeah, check you later.